Odds ratio and risk ratios are an estimates of an effect size that can be calculated when performing meta-analysis with an outcome that is binary. Odds ratio is an effect size that is estimated when the outcome is binary. Binary outcome is a variable that have two levels in it, binomial or dichotomous. Two levels such as agree, disagree, yes or no, smoke, doesn't smoke. Meta-analysis is a statistical method that is used to combine data extracted from several independent clinical or research studies that addresses the same scientific or clinical question. The objective from performing meta-analysis is to calculate the overall pooled estimate of the effect size from separate independent clinical or research studies. Forest plot is generated from the meta-analysis. Forest plot is a diagram that summarizes the output or the outcome from the meta-analysis, or the outcome of statistics from the meta-analysis. The forest plot consists of three sections: a descriptive section, which includes the description for each study and the calculated estimate effect size, the 95% confidence interval, the p-value, and the weight percentage. A second section, which is a diagrammatic representation of the descriptive statistics, and a third part which shows the overall estimate effect size from those pooled studies, with heterogeneity test and I-squared value to examine and test degree of variability among the result from those several separate research studies. If you find this video useful, do subscribe and click on the notification bell to receive and get latest release of videos to the channel, and click on the like and click on the share to share the video to others, so the channel will grow and develop further to include a wider and a larger scope of different statistical method that can be done in SPSS, Excel, Stata, Jamovi, R Statistics, GraphPad, Prism, GMP, and Revman. So what is odds? Odds measure the likelihoods of a particular outcome. It is the ratio of the probability that the event will happen to the probability the event will not occur. So it is calculated as the probability of the event occurring divided by the probability of the event not occurring, which is 1 p. Probability of event occurring is given a p simple, and not occurring is 1 minus p, or a letter q. What is odds ratio? Odds ratio calculated as the ratio of the odds of the outcome in the exposed group compared to the odds of the outcome in the unexposed group. So it does measure. So odds ratio is a effect size, an estimate of the effect size that measures the level of association between exposure and outcome. So here you have two variables, a variable for exposure and an outcome, and the association between those two variables are or is calculated. So the odds of the outcome being associated with the exposure compared to the odds of the outcome being unrelated to the exposure. So the odds ratio is calculated as shown here. OR equal to the odds in the exposed or experimental or intervention divided by the odds in the unexposed, the control, the reference category or group. So the OR is different from odds. Odds is the probability of an event occurring relative to not to the probability of not occurring, and the OR is the odds in the exposed relative to the odds in the unexposed. So here I had inserted an example to clarify the concept of the odds ratio. Here two groups has been assigned, treated and control, and the drug efficacy was counted and measured, and the success of the recovery was recorded as here 45 for the treatment group, and those that did not recover using the treatment were also recorded, and the total number of participants in the treated group is given here. For a control, there was no drug or treatment introduced, and 10 individuals had recovered from the disease or the condition, and 55 failed to recover. Total number of participants were 65. So here for the treated group, the event happening is 45 and the event not happening is 15, and the same for the control. Event occurring is 10, events not occurring is 55. So the odds for the treated is 45 divided by 15, and for the control is 10 divided by 55. To calculate the odds ratio, then divide the odds for the treated or the exposed to the odds for the unexposed or the control, as shown here. 45 divided by 15, and then that's divided by 10 over 55. This gives us the value of 16.6. So the odds ratio for this treatment is equal to 16.6. So what does this value indicate? This value indicates that there are 16 times higher odds of individual who are treated with the drug to recover from the condition compared to a control group. So when the odds ratio is greater than 1, this suggests a positive association. When the odds ratio is less than 1, this suggests a negative association. And when the odds ratio of 1 indicates no association. The odds ratio is often used in a case control studies and is suitable when the outcome is rare. Here I had inserted a data for 12 studies to perform meta-analysis, and each study had recruited participants who have been assigned to either treatment group or a reference group, and the number of events occurring in the treatment is recorded, and in the reference is also recorded, and the number of event not occurring is recorded for treatment and for reference. So here we have a binary outcome which has only 2 levels in it, either the event occurring or not occurring. Then the effect size estimate will be the odds ratio. The following graph shows the meta-analysis for the previous data, and as had explained already, the forest plot consists of 3 sections: descriptive statistics, diagrammatic representation, and an overall estimate of the effect size with heterogeneity test. The plot shows that there are 12 studies. The odds ratio, log odds ratio for each individual study is calculated, and the standard error is also produced. A 95% confidence interval with a lower and upper limit is given, and a p-value is generated, and a weight percentage which reflects the contribution or the influence and the contribution of the sample size on the overall meta-analysis. This plot was generated in SPSS. The second section here is just a representation of this section here. These square, blue square symbols represent the effect size, which is the odds ratio for each individual study. The horizontal line is the 95% confidence interval, and the sizes of these squares varies depending on the weight percentage or the sample size. Larger sample size have larger square. The red dashed line represent the line for the value, which is the overall estimated effect size or the overall odds ratio. The diamond shaped structure here is the overall odds ratio for the 12 studies, and as shown here, the overall odds ratio is 2.79, and a 95% confidence interval is also produced, and the horizontal line is the 95% confidence interval. The third section here shows the overall with the heterogeneity test, which examine the degree of variability among the results from those 12 studies, with an I-squared generated, which is 12%, which is a low level of heterogeneity with a p-value greater than 0.05. So thus the odds ratio is used as an estimate of the effect size in performing meta-analysis for data that are binary. Risk ratio, which is an effect size estimate, can be used when the outcome is binary. What is risk? Risk is the probability of an event occurring. So it is the proportion of individuals with a certain characteristic within a group. So risk can be basically represented in this equation: number of cases divided by the population at risk. So what is a risk ratio? Risk ratio is also known as relative risk. It is the ratio of the probability of an event occurring in a treatment or intervention or exposure group compared to the probability of an event occurring in the control or unexposed or reference group. It is calculated as the risk of an outcome occurring in exposed group compared to the risk of outcome in unexposed group. So it does measure the association between exposure and outcome, and the risk ratio can be interpreted as the risk of an outcome associated with the exposure compared to the risk of the outcome in the unexposed group. So the risk ratio is the ratio of the risk in exposed group to the risk in the unexposed group. It is a relative difference between two proportions, and it is simplified in this formula. Risk ratio is equal to risk in the intervention divided by the risk in control. So here I had inserted data for study that had looked at and investigated the effect of a new treatment on a condition. Here we have two groups, treated groups and control group. And the event occurring in the treated group is recorded as a success, and the event not happening is recorded as failed. And the total number of participants in the treated group is given here. For the control, also the number of cases or participants who had the event or who had succeeded in recovering from the condition is recorded here, with those who did not recover or the event is not occurring is also recorded here, and the total number of participants for the control is recorded. So here we have a binary outcome in which there are two levels in it, either event occurring or not occurring. To calculate the risk ratio is equal to the risk of the exposed to the risk of unexposed, risk of treated to the risk of controlled. So the event in the treated is 45, which is the number of cases, divided by the total number of population at risk, which is 60 for the treated. And for the control, the number of cases is 10 divided by the population size at risk, which is 65. And once we divide this all together, it shows a ratio of 4.8. So there is a risk ratio of 4.8. This is the way to calculate the risk ratio for a binary outcome. Risk ratio can be greater than 1, which indicates an increased risk as it is an association, and a risk ratio less than 1 indicates decreased risk, and a risk ratio of 1 indicates no difference in the risk between groups. The risk ratio is commonly used in cohort study and is suitable when the outcome is more common. Here I had inserted data for 12 studies that investigating the efficacy of a drug on treating certain condition, and the following scores were included. Each study had segregated the participant into intervention or treated group and a control, and the number of events occurring in the intervention is counted, and the number of no event is counted, and the total number of participant is also calculated for the intervention. And for the control, also the number of events or number of cases at risk is counted, total number in the control. To perform meta-analysis based on estimate effect size, which is a risk ratio, the risk ratio can be calculated and estimated as an effect size for the intervention compared to the control. And once meta-analysis is performed, following forest plot is generated from the previous meta-analysis of the data. And as shown here, the forest plot has 3 parts: the descriptive part, the diagrammatic part, and the overall effect size estimate with the heterogeneity test. In the first part, the 12 study is listed here with the risk ratio calculated for each study with 95% confidence interval, p-value for the risk ratio, weight percentage, which reflects the influence of the sample size on the meta-analysis. The second section is diagrammatic representation of the descriptive statistics, with the square symbol here represent the risk ratio for each study. There is variation in the size, and this is due to the weight percentage, which reflects sample size, as larger sample size will have larger square. The horizontal line is the 95% confidence interval, and the diamond shape here is the overall pooled calculated risk ratio with a 95% confidence interval represented by the horizontal line. The vertical red dashed line represent the calculated pooled risk ratio, which is 1.58. The third section here is the overall calculated risk ratio with a p-value and a 95% confidence interval and a heterogeneity test to determine and assess the level of heterogeneity between the results from those separate 12 studies, with an I-squared value of 9%, which is very low, and a p-value greater than 0.05. So there is low level of heterogeneity between the data extracted from these 12 studies. So what is the difference between odds ratio and risk ratio? As I have described previously, the odds ratio is the ratio of the odds of an event occurring in the treatment group to the odds of an event occurring in the control group. The odds ratio is the ratio of two odds. The relative risk or risk ratio is the ratio of the probability of an event occurring in the treatment group to the probability of an event occurring in the control group. So it is the relative risk is the ratio of two probabilities. If you have a data and you want to perform data analysis and you are looking for one-to-one private tutoring sessions or a training course on how to analyze the data using any of these packages, SPSS, Stata, Jamovi, R-Statistics, GraphPad, Prism, or any of the others, then do contact me.